Hey, it's time for Security Now. Kind of a slow week in the security. I guess the hackers took Thanksgiving off. But Steve does have a What Could Possibly Go Wrong segment, a picture of something that really did go quite wrong, and a look at the next generation Rowhammer. They're calling it ECC or exploit. Stay tuned. Security Now is next.
Netcasts you love.
From people you trust.
This is Twit.
This is Security Now with Steve Gibson, episode 699, recorded Tuesday, November 27th, 2018. ECCploit. Security Now is brought to you by Wasabi Hot Cloud Storage. Wasabi offers the next generation of cloud storage with the highest possible durability and security. See for yourself with free unlimited storage for a month. Go to wasabi.com, click free trial, and use the code SecurityNow. And by DigitalOcean, the easiest cloud platform to deploy, manage, and scale applications. Over 150,000 businesses rely on DigitalOcean to remove infrastructure friction and deliver industry-leading price performance. Sign up today and receive a free $100 credit at do.co/twit. And by CacheFly. Over 95% of CacheFly WAF users are running in full blocking mode. Can your WAF say that? And just for Twit listeners, receive up to $2,000 in credit when you switch to CacheFly before January 1st. Learn more and get a complimentary quote at securitynow.cachefly.com. It's time for Security Now, the show where we cover your security and privacy online with our friend. It's kind of like your neighbor, Steve Gibson. If your neighbor were like the king of, computing. Hello, Steve.
Hey, Leo. It's great to be with you again for this post-Thanksgiving episode of Security Now. In gathering together all of the news of the week, I came up kind of short. Luckily,
we had a bunch. I don't mind.
Yeah, I think the hackers and the attackers all
took the week off.
They enjoyed their long Thanksgiving week. Of course, that's not, I guess, globally celebrated. But anyway, it was slow. We do have some interesting things to talk about. I wanted to give my own take. I saw that you guys led off MacBreak Weekly with it to talk about what was initially my concern over Apple's presentation yesterday in front of the Supreme Court, because we know how important it is to have a curated app store. And I was like, oh, goodness.
That's a good point. There's a security app.
It's like all there. It's all there is.
Yeah.
And we also have Google and Mozilla looking to remove support for, believe it or not, I mean, you will believe it, because who uses it anymore? FTP from the web browsers.
Oh, I guess, yeah.
Not gone yet, but
it's still in there? What a surprise.
Yeah. I know. Whoever uses that. Which is not to say there's anything wrong with FTP. Calm down, you old timers. I still
use it all the time. Yeah. I use SFTP.
Yes, there are, like the alternatives people want. Then we have, from our What Could Possibly Go Wrong department, browsers considering looking for permission to leave their sandboxes. And it's like, oh, really? We have some interesting post-Troy Hunt, Our Passwords Immortal listener feedback from last week's topic. And then we're going to take a close look at the next step in the evolution of Rowhammer attacks.
Oh, boy.
Which do, as Bruce Schneier once opined, only get better, or maybe worse. Anyway,
more successful.
As a consequence, and this comes from our friends Herbert Boss and his team, although a different team at VU University in Amsterdam, or VU Amsterdam University. Anyway, they named it ECCploit. And when I was kind of looking at that, I realized, okay, how would you pronounce that? Well, ECC is So it's exploit.
Exploit. Oh, clever.
So, and Leo, we have a picture of the week that, again, the old timers here, they'll be like, oh, I recognize that. That looks like what I have. Anyway, a lot of fun, I think, this week for our listeners, and a bunch of good stuff.
Well, and our sponsor today for the show is Wasabi. It's kind of appropriate. I kind of know a little bit about Wasabi because David Friend, who I consider a good friend and a serial entrepreneur, the guy who he invented the ARP synthesizer, which is kind of a claim to fame. That was practically right out of school. You may know better his other company, Carbonite. And when he and his partner at Carbonite created the company, they actually solved a fairly big problem in cloud backup. They figured out a way to write to disks directly, saving speed, saving space, making it really much more affordable to back up to spinning hard drives. So David Friend and Jeff Flowers started a new company taking advantage of these patented technologies called Wasabi. Now, what is Wasabi? Well, besides being a hot horseradish relish for your sushi, Wasabi is also hot cloud storage and offers, I think, a very compelling alternative to other cloud storage providers you might be looking at. Of course, one of the number one secure concerns when you're migrating to the cloud is security, clearly. Although I have to say, given what I've seen of people's on-premises security, it probably is the case that you're more secure in the cloud where professionals are maintaining the security and integrity of your systems than letting Joe from accounting manage the hard drive in the closet. Frankly, with Wasabi, security is almost always greater than on-premises storage. And talk about durability, 11 nines of durability, the highest possible. That's partly improved by the fact that you can actually declare some data immutable. This is brilliant. You can say this data cannot be changed or overwritten. And if for one of the things that really worries people about on-premises storage and then propagating to cloud storage is ransomware, immutable data can't be touched by ransomware, can't be touched by somebody inadvertently deleting it all. It can't be changed in any way. And there's definitely data you have that you would like to make immutable. With 11 nines of durability by itself means your data is very safe. On average, that's one file every 650,000 years. Not too often. Tier 4 data centers hosted in highly secure facilities. They're fully redundant. You're safe from hackers. You're safe from malware. You're safe from yourself. HIPAA, FINRA, CJIS compliant. That's good. That tells you actually right there something about the security and reliability of Wasabi storage. You even get active integrity checking, where all the objects stored are checked for integrity automatically every 90 days. So there's no bit rot, no worry that stuff you've got stored up in the cloud might be modified or changed over time, just by age itself. It's not just highly secure; it's highly disruptive technology. And I kind of buried the lead on this one, the headline, because of this patented technique that Jeff and David invented. Wasabi lays data on disks sequentially, not in blocks. That means their storage is 80% cheaper and 6 times faster than Amazon's S3. That's pretty sweet. If you go to wasabi.com, you'll see that they have a trial that lets you use a terabyte of storage free for 30 days. This is a good way to test it. Wasabi, wasabi.com. And as a way of testing it, because you're listening to Security Now, if you use the code Security Now at wasabi.com, you'll get unlimited storage for a month. You could pump a lot of data up there and really tax the Wasabi servers and see how they do what they do. It is the future of cloud storage. And I have to mention, although it's not in the ad, they have something big coming up on Thursday that you're going to want to find out more about. The future of cloud storage will be revealed on November 29th. And it doesn't include the 800-pound gorilla, if you know what I mean. Find out more. Wasabi, really exciting. They're actually going into the lion's den. They're going to do it at AWS reInvent. I love it. Wasabi, that's bold. Wasabi.com. Don't forget the offer code Security Now for unlimited storage for a month, so you can test it out. Add it to your list of potential providers. I think you'll be glad, and your boss will be glad when they save 80% on the storage bill. Now back to Steve, and I guess you want to do the picture of the week?
I've been staring at it, and I was imagining you accept a job, a new job as the IT guy at some company, and your boss says, "Oh, and we have an intermittent connection somewhere."
Can you find it? This is somebody's wire closet. But you know what? I've been in that closet.
Oh, I think we all have. I don't know what it is about these closets that evolve this way. They almost without exception, they start off neat and planned. In fact, you can see on the back wall, it looks like there's some nice loops of a black something, like they're all tacked down. There was like somebody had this dream of we're just going to have the nicest, wire farm. And oh my goodness, I think my favorite one is this tan one that's coming across the walk path. I mean, it's one thing for them just to be kind of going down on the sides, but you have to duck under this one that's going kind of diagonally.
Oh, Lord.
From left to right.
This is not as bad. We weren't as bad, but it is a little bit what it looked like at the brick house because we rushed over there and we added stuff. But when we moved here, and really kudos to Alex Gumpel, Burke McQuinn, and John Slanina, our engineering team, and Russell, too. When we moved here, we already kind of knew all the connections, all the boxes. We already had everything. And they took the time, and I'm proud to say, our server room does not look like this.
Oh, God. I just don't notice. Look at the top in the middle where there's other wires that are looping over and pulling down.
No. That's ridiculous.
So they had to cross over, but they didn't want to block the walk path. So they hung them over the other wires.
Man.
It's like pulling them down. It's like, oh, yikes. Yeah, I think, remember the old saying, no battle plan survives first contact with the enemy.
Yeah.
And there's an analogy there. It's like, you initially know where everything should go and you lay things out, and then, something comes along and you got to change things, and it's like, and you don't have time. So it's like, okay, well, I'll just do this, just kind of a hack here real quick. We'll just run these wires over here, and then I'll get back to this, when I have time. And then something else happens before you are able to fix that last one, and it piles up, and the result is this.
This is our old wire closet before we moved, and well, it's not that bad. Although if you go around behind it, it is pretty.
That was the basement below.
Yeah, this is the basement in the brick house.
Yeah, it was, and you guys you had an advantage of an entire floor that was essentially your wiring closet.
Right.
You were able to drill down wherever you were, and you'd be down in a completely available space to then run cables to somewhere else.
Do you have a picture anywhere of, by the way, there's the engineer, Scotty, who was the patron saint of our closet. Do we have a picture anywhere of our current setup? Go take one and you send it to me, because I'm very proud. John just came in. I'm very proud of what our team did, because they made it look beautiful. And you know what's important, because if you have, exactly as you said when you began, if somebody says, hey, there's some intermittent problem, you don't want to be the one who has to go in there.
It's like, I can't even see the lights. What are you talking about? That's just like totally obscured. So while we're waiting for the photo of the
much improved
the pride of your current wiring closet,
yes,
I wanted to bring up a topic that you guys mentioned on Mac Break Weekly at the top of that podcast, which I took from a Security Now angle.
Yeah, and that actually, I'm thrilled you did, because we were discussing the Supreme Court hearing yesterday over the really, it was more about the standing of the plaintiffs in a class action lawsuit against Apple, claiming that the App Store was a monopoly, and that people should be able to buy apps from other sources on iPhones.
Exactly, and that's of course what set me off, because we know how unable to make those kinds of decisions end users are. They're just not. They shouldn't have to be, and they're not equipped to protect themselves. So at issue is whether Apple's App Store, through which, as we know, it alone can offer and sell applications for its mobile devices, constitutes a monopoly and gives it monopoly power over all sales of iOS platform apps. And as you mentioned before, correctly, the lawsuit, which is known as Apple Inc. versus Robert Pepper et al., it's a class action, and I feel, as we all do, that, and as you said on the podcast, these things are generally just, for ambulance chasing attorneys to line their pockets, and the people who are members of the class typically receive pennies. So this suit has been around for almost a decade, and it argues that Apple's 30% cut, which they take of all App Store sales revenue, is excessive and anti-competitive and amounts to price gouging, since consumers have no alternative other than to purchase apps for their devices at Apple's, quote, inflated, unquote, prices. On the other hand, come on, like, really? But this issue is, as I said, of interest to us on this podcast, because we've often noted that consumers can act unwisely and may be poorly informed about the true dangers of obtaining applications which have not been rigorously scrutinized, vetted, and curated, which is, I think, a vital service that Apple performs, and not easy. I mean, we've often talked about how difficult it is, and yes, they make mistakes, but largely, for example, it is that and some of the other lockdown, one could argue monopolistic things that Apple does are what makes the iOS a more secure platform today than Android. And we know that Google has been making efforts to sort of catch up in that regard. So as is often done in the law, and as you mentioned, Leo, Apple is not defending itself against that allegation, but their attorneys said, "Oh, let's, here's how we'll spin this." What they've been arguing is whether the consumers who are bringing this complaint have grounds for that complaint in the first place, and this is known as standing. Apple is arguing with the plaintiffs, essentially, of these litigants, whether or not they have standing to sue Apple over any of this. So, I mean, aside from even looking at the issue, Apple's taken the position that only its developers, who are being charged a 30% sales commission, as Apple frames it, on the retail sales of their apps, would be damaged if Apple's conduct was found to be unlawful, and that it would be up to them to complain, that is, them, the developers, not the end consumer. The precedent which the Supreme Court is revisiting was, and that's the reason it's gone to the Supreme Court, after Apple has already won in the appellate court. I mean, so the U.S. Department of Justice has already come down on Apple's side. So it's like, okay, we're taking this to the Supreme Court. So the precedent was set back in 1977 in a case known as Illinois Brick Company versus Illinois, which was a dispute in which the court ruled in favor of concrete brick manufacturers. The state of Illinois had sued the brick makers for allegedly inflating their prices, causing an increase in the cost of public building projects, which, of course, the state of Illinois was upset about. the court ruled then that even though the increased brick costs might hurt Illinois indirectly, only the contractors who actually bought the bricks had standing to sue. And so that established what has become known as the Illinois brick doctrine, which gets hauled out every time an issue like this comes up. And that says that only the direct purchaser of a good can collect damages from a monopoly holder. So as I said, the U.S. Department of Justice has already ruled that the Illinois brick case was controlling here, whereas they're arguing that the Court of Appeals misapplied the Illinois brick doctrine, which, of course, is what they want the Supreme Court to agree to. So Apple argued yesterday that it is not directly selling apps to iPhone users, rather that they're acting as an agent for app developers who ultimately are selling their wares to consumers. And so they're saying in exchange for the commission Apple takes on app sales, the company provides access to its vast user base and performs other services such as malware detection and so forth. So anyway, we know where we are on this. One way or the other, it would be a disaster if we're a long way away from this happening, but it would be a disaster if the government ever forced iOS apps to be available from anywhere that a user wanted them. The presumption is, oh, great, we'll save 30%. First of all, no, it's not that, you're not going to get something useful for less than 99 cents or free with in-app purchases. That's just not going to happen. But mostly we lose the ability for Apple to control this very attack-prone surface that our mobile platforms represent, and just stop being able to protect consumers from themselves, because we just know people would just be downloading stuff from everywhere and it would be a disaster. So yikes. And it's pretty much what you guys said on MacBreak. I thought it was interesting though that bricks came into it.
Yeah, I mean, the disaster you're describing is what happens on PCs today. You can download an app anywhere, from anywhere on a PC. Microsoft has tried with Windows 10S, to make a version of Windows that is only available to the App Store. And the first thing anybody does who gets a PC with Windows 10S on it is disable that so they can download Chrome and other things. I mean, when you get Chrome, you're not getting it from the Microsoft App Store. You're getting it from Google.
Yeah,
and I think the right to do that is great. But maybe a mobile platform is a little bit different and should have a restricted app store. I honestly think if that's what you want, you should get an Android phone. It's more appropriate.
Right.
But it's an interesting case. A class action case is not going to change anything, even if they win.
Let me show
you our
wire
closet. This is the current. So let me just so you remember the wire closet.
Oh, come on! Really?
That from earlier. This was the picture of the week. This is our. It's called the Video Hub, which has all the cameras are going into one side, and then all of the outputs are going to another side. The whole server room looks like this.
That's a thing of beauty.
Isn't it nice?
That really is.
They're not even showing the best stuff. And there's some beautiful cable bundles and things going through conduit. Those cable trays up above. Everything's done beautifully. And it's important to do it that way. We even custom cut like these RCA cables to be custom length so you wouldn't have a lot of extra stuff.
Yep. Very nice.
Around. They did a beautiful job. I just want to make sure they get Alex and Gumpel and Russell and Burke McQuinn get credit because they just did a fabulous job. Yeah, it's clean, right? They're not, I'm sorry, did I say RCA? They are not RCA cables. They are, what are those things called? BNC, thank you.
It's video, SDI.
SDI, BNC cables. Those are the ones that lock. We don't use any of that cheap RCA crap. Yeah, isn't that nice? I'm proud of them. I want to give them kudos because they did a
Now,
nice
if we only knew who was running that closet that's the picture of the week, we could send your team over there.
No, they can't have them. They can't have them.
And you'd see them about 5 years later after having nervous breakdowns.
This is only because we moved, right? We were able to, because nobody was going to go in that old rat's nest until we moved.
That's right.
Right?
That's what you do. Once it gets out of control, you just find
move.
a new location. Exactly. Whoa. And you just do it. Okay, now this time we know how to do it.
Yeah.
So, very nice.
Yeah. I mean, those labels, guys, didn't we give you a brother label maker? Couldn't you do a bit? I mean, come on. They're a little handwritten. But other than that.
So, Bleeping Computer had an interesting posting about the endangered status of web browser support for the age-old FTP protocol. And I'm sure, the old-timers among us have put in FTP:// and the name of an FTP server, and a browser today's browsers will understand that, will act as an FTP client, will bring up a connection to a remote FTP server. For those who don't know, that's file transfer protocol, and display the files that are in a directory, and you can click on a file and download it. So, I mean, it's not that different than a browsable directory on a web server, on an HTTP server. The trouble is that FTP is barely and rarely used anymore by the mass of Chrome and Firefox users. I saw some stats that were something like 0.1% over some period of time. So it's not absolutely zero, but it's like the problem is that there have been various attempts to secure FTP in the way that HTTP was secured, but they never took hold, and there are some technical challenges. I recall talking about the NAT traversal challenges of supporting FTP many years ago on this podcast. The trouble is, unlike HTTP, where a single connection is made to a server, FTP by default, there is a variant that is known as passive FTP, but its normal operation uses a pair of TCP connections, one for the so-called control channel and a second connection for the data channel. That second channel is allocated dynamically, where the FTP server that answers the incoming data channel connection, in its response, after they negotiate, tells the client which service port it should use to connect to for its data link. Who knows why that was the way it was designed in the old days, but that's the way it was designed. So this, of course, creates a problem for firewalls and NAT routers, which adopted the practice, which is what we talked about years ago, and which it remains in use today, of actively snooping on the FTP protocol control messages in order to determine which secondary connection they need to allow for inbound. So when they see the servers that is behind them telling an external FTP client, oh, make your inbound data connection on port whatever, the NAT router sees that and goes, ooh, and opens up. It like performs its own NAT mapping, opening up on the fly a port to receive the now expected incoming FTP client data connection. So it's now that's gets complicated when you add security. In fact, it becomes impossible if the FTP control connection is encrypted using something like TLS, since what is then a deliberate man-in-the-middle firewall or NAT router cannot determine the TCP port number for the secondary data connection, which has been negotiated between the client and the FTP server, because it's encrypted. There have been, as I mentioned, some attempts to secure FTP, but mostly, first of all, that they have succeeded, like doing FTPS, simply layering TLS on top of FTP in a way analogous to the way we added TLS to HTTP wouldn't work for that reason, for the fact that we're currently depending upon being able to snoop on that traffic in order to handle the FTP protocol in its standard mode. And of course, there's the whole issue of the web browser's attack surface being kept open and expanded for this use for a protocol that virtually no one uses through their browser any longer. The point is that the browsers are currently supporting this and thus have an available surface for attack that they have to keep maintaining even though it's not in use. So it's not that FTP itself isn't a useful application protocol for cross-internet file transfer, but first of all, standalone full-featured FTP clients are available for every platform. I don't know if our listeners know, but Windows has long had an FTP client command line. If you open a command line and enter FTP and hit enter, you're in an FTP client. And if you type help, you get a large list of available commands and you can do FTP stuff. And then if you type quit, you'll exit the client and come back to the Windows command prompt. And of course, all operating systems that are in use today on some level support it. And so what's happened is that the insecure and insecurable FTP has become sort of the lowest common denominator for internet file transfer. First of all, oftentimes just HTTP with S. HTTPS will allow you to download files. GRC has some directories where I explicitly make them available for developers to grab stuff that I'm working on. When I was working on SpinRite 6, I had a SpinRite 6 directory and people could browse around in that. And in fact, I had to deliberately put a text file in the directory starting with an underscore, so it would be at the top of the list, that says this directory is deliberately publicly accessible, because I would get helpful notes from people saying, Steve, you realize you got an exposed directory on your, it's like, yes. Anyway, so the point is you can do this in a secure fashion already with HTTPS if all you want to do is make files available for download, and even, with directory browsing and the other things that FTP allows. And as you mentioned, Leo, when we were talking about this at the top of the show, there have been successful variations. There is SCP, which is the secure copy.
Actually, that's the one I use. I use that one all the time. Yeah.
Yes.
That's under
SCP.
SSH, right?
Exactly.
Yeah.
And then there's another one. There is an SFTP, which is another use of SSH for file transfer. There's even FISH, FISH, which is file transfer over shell protocol. So, there have been solutions to this. It doesn't affect anyone today, but just sort of as an early note to our listeners, if something you're doing, and I can't imagine why, but if it seems it's like, okay, if something you're doing requires FTP through a browser, just an early heads up that both Google and Mozilla are kind of looking at this thinking, we got to have to retire this somehow. So it may well be that at some point in the future, we're discussing the announcement that version X of Chrome and Y of Firefox are planning to remove their native support for this venerable and increasingly obsolete protocol. So, it may happen. From our what could possibly go wrong department, you're not going to believe this, Leo.
Mm-hmm.
I just okay. There is a discussion underway at Google and on public forums of the so-called Writable Files API, intended to simplify local file access. And because I think we're going to have a relatively short podcast, let's take a second break, and then I'm going to dig into that with our listeners.
Dealio. Now would be a good time, though, to talk about our sponsor, DigitalOcean. It's an empowering technology. I love DigitalOcean, and if you mention DigitalOcean to any software company or startup or developer, they'll know immediately what you're talking about. It's a very easy cloud platform for developers or anybody who wants to put an application on the web. I know people actually who host their blogs on DigitalOcean. It's a server that you control that runs your software. They call them droplets because droplets in an ocean. But let me show you. I'd say, all right, I want to create a droplet. By the way, you see there's other things you can create. You can add storage to existing droplets. You can route existing domains. You can increase droplet security with cloud firewalls, reserve IP addresses for droplets. They can do load balancing. They've got a lot of very sophisticated stuff, but I'll start with the basic droplets. I want to set up a WordPress server. Notice I can choose Ubuntu, FreeBSD, Fedora, Debian, or CentOS, or I can go with containers, CoreOS, Fedora, Atomic, and then choose what I want to run Docker on or whatever the container is I want to run. There's also one-click apps, and this is kind of great for developers. If you, for instance, you need a MongoDB or you want to do a Ruby on Rails, you need a LAMP stack, MySQL, PHP. I can go on and on. Let's say you want to have your own Git system. Just do the GitLab, one click. But I'm going to do the one click on WordPress, choose a size. And since this is just going to be for me playing around, I'll choose the smallest size, $5 a month. I get a CPU, a gigabyte of RAM, 25 gig SSD. I like this, 1,000 gigabytes, a terabyte of transfer a month. If you want, you can enable backups. They're automatic. That's $1 a month. Add block storage as needed. By the way, this is just the starter. I can add CPUs. I can add capacity. Choose your data center region. I always choose San Francisco too because that's where we are. But there are Amsterdam, New York, Singapore, London, Frankfurt, Toronto, Bangalore. You can choose private networking, IPv6. You can have the cloud in it to configure your droplet. Turn on monitoring. I always turn on, since we're talking about security, SSH keys so I can log in via SSH, not with a password, but with the SSH key. That's another nice feature. There we go. I think I got all those. That took the longest part of this. This is now going to be provisioned, and I'm going to have a public server with a public IP address. See, I have a Docker server now, Node.js running. I have Django on one. This is a Ghost, another blogging platform running on another. I've got how many droplets? 1, 2, 3, 4, 5. This will be the 6th droplet. So easy to set up. I can do it during the commercial. It's about a minute or two. And this is a good company for servers. 99.99%, 4 nines uptime, SLA. As I said, you can get a cloud firewall, monitoring and learning, full DNS management, global data centers. It's done. My droplet's ready. Not a day, not an hour, not even 10 minutes. My droplet is ready. I can log into it, SSH into it. I could start developing. I could start setting up my WordPress blog right now with a public IP address and everything. The API is easy too, so you can even do this under program control. 150,000 businesses now, including some of the world's fastest growing startups, rely on DigitalOcean. No more infrastructure friction. No more having to call somebody to get it all set up. Just boom, as you need it, deploy servers. When you don't need them, spin them down. It's really easy. There couldn't be a simpler solution. If you want to make a minimal viable product for your startup idea and have it ready, up and running tomorrow for investors, DigitalOcean will do it. If you need to ad servers because you've got a complicated MySQL setup, DigitalOcean it couldn't be easier, and it couldn't be more affordable. With all those droplets I have set up, my usage this month, $24.25. I love DigitalOcean. And just to be complete, for completeness, I'll show you how easy it is. When you're done with a droplet, to destroy it, destroy my droplet, and it's gone. I love that. You want to sign up today, you'll get a free $100 credit. That'll get you, depending on what you do, that can get you many months of DigitalOcean. Go to do.co/twit. I'm going to actually, while I'm at it, destroy some of these other ones I'm not using anymore. do.co/twit, a free $100 credit. It's a great way, I'll give you some examples. If you're using an iPad, but you want to have a server that you can write and deploy Node.js stuff, you can SSH from your iPad using a program like Blink to your DigitalOcean server, have Emacs running, have your coding environment up and running. This is so versatile. Father Robert used to use I think he probably still does, used to use DigitalOcean to try stuff, set up stuff, write code. do.co/twit. For learners, for startups, for anybody who needs a web presence for any variety of reasons, it's DigitalOcean. do.co/twit. $100 credit awaits. Now, we go back to you, Mr. Steve Gibson.
Okay, so from our what could possibly go wrong department.
Possibly go wrong.
Okay, so this is the I think this is actually going to happen at some point. So, yikes. The Writable Files API, simplifying local file access, is the heading of this sort of proposal. So and I'm just reading from Google's, I've got the link here under the developers.google.com. What is the Writable Files API? They say, today, if a user wants to edit a local file in a web app, the web app needs to ask the user to open the file. Then, after editing the file, the only way to save changes is by downloading the file to the Documents folder, or having to replace the original file by navigating the directory structure to find the original folder and file. They say this user experience leaves a lot to be desired and makes it hard to build web apps that access user files. The Writable oh god. Okay. The Writable Files API is designed to increase interoperability of web applications with native applications, making it possible for users to choose files or directories that a web app can interact with on the native file system and without having to use a native wrapper like Electron to ship your web app. In other words, Electron creates an environment that a web app can run in natively, so it's not in the browser. Google, of course, is wanting to release the restraints on web browsers. They say with the Writable Files API, you could create a simple single file editor that opens a file, allows a user to edit it, and save the changes back to the same file. Or a multi-file editor like an IDE or CAD-style application where the user opens a project containing multiple files, usually together in the same directory. And there are plenty more. Okay, now, as I was thinking about this, I thought rather than filing this in the what could possibly go wrong department, maybe this should really have been in the we should have seen this coming department. Our web browsers first began pulling crap from all over the internet to fully monetize the pages that we visited, sometimes by mistake. Then they got us hooked on JavaScript so that nothing works anymore without it. But compared to native OS apps, JavaScript performance was bad. So first we got NACL, that was the native client, which was very clever, but what never achieved critical mass. Then consensus was finally reached around WebAssembly, so that now code running from random sites on the internet that we visit can much more efficiently run Monero mining on our machines while we're trying to figure out what that pop-up says that's asking for permission to store cookies on our browser after we leave the page that we visited by mistake. So what we see is a history of desperation on the side of the web browser apps to become a first-class native-born citizen of our OSs. And we know that the whole sandboxing thing has to really be chafing the web browser guys. They want to be real apps on our machines. They don't want to be stuck behind any safe enclosures. They've got speed now, so next up is access. Anyway, so there is a discussion, and the good news is they recognize, they're playing lip service to the security issues. Under security considerations, they said the primary entry point for this API is a file picker, which ensures that the user is always in full control over what files and directories a website has access to. Okay, good. Every access to a user-selected file, either reading or writing, is done through an asynchronous API, allowing the browser to potentially include additional prompting and or permission checks. The Writable Files API provides web browsers with significant access to user data and has potential to be abused. There are both privacy risks, for example, websites getting access to private data they weren't supposed to have access to, as well as security risks. For example, websites able to modify executables, encrypt user data, and so forth. The Writable Files API must be designed in a way as to limit how much damage a website can do and make sure that the user understands what they are giving the site access to. Oh, Lord. So there is on GitHub, there is a discussion of this and an explainer. And although the following is a little bit redundant, we have time. So I want to explain what they're thinking. So under the proposed security models, they say, by far the hardest part of this API. Okay, now I would just saying no would probably be a good idea. But they said by far the hardest part for this API is, of course, going to be the security model to use. The API provides a lot of scary power to websites that could be abused in many terrible ways. Okay, people, I'm saying to Google, are you hearing yourself? It's like, yes, and it's going to happen. But, okay, we could we could do a CAD app. We could do a multi-file editor. We could open a project that then has access to all the files in the project. What could possibly go wrong? They said there are both major privacy risks, websites getting access to private data they weren't supposed to have access to, as well as security risks, websites modifying executables, installing viruses, encrypting the user's data, and demanding ransoms, etc. So, great care will have to be taken to limit how much damage, how much damage. Yeah, let's limit how much damage a website can do. By all means, I'm for that. And they say, and make sure a user understands what they are giving a website access to. Oh, yeah, right. Our moms are going to understand this. Can you just see the website saying, in order to do what you want. We need to have, anyway, persistent access to a file could also be, get this, persistent access to a file. So they're suggesting that websites have persistent access to files on our systems. Persistent access to a file could also be used as some form of super cookie, but of course, all access to files should be revoked when cookies/storage are cleared. So this shouldn't be too bad. Oh, okay. The primary entry point for this API is a file picker, i.e. a chooser. As such, the user always is in full control over what files and directories a website has access to. Furthermore, every access to the file, either reading or writing, after a website has somehow gotten a handle is done through an asynchronous API. So browser could include more prompting and or permission checking at those points. This last bit is particularly important when it comes to persisting handles in indexed databases. When a handle is retrieved later, a user agent might want to reprompt to allow access to the file or directory. So this suggests that they're proposing that websites would by default have enduring access to specific files or projects or whatever on the user's machine. They say other parts that can contribute to making this API as safe as possible for users include limiting access to certain directories. Oh, well, that would be good. That would be handy. For example, they say it is probably a good idea for a user agent, that is the browser, not to allow the user to select things like the root of a file system. You think? Certain system directories, the user's entire home directory, or even their entire downloads directory. Also, limiting write access to certain file types, not allowing websites to write to certain file types, such as executables, will limit the possible attack surface. And then other things user agents come up with. Okay, so, we've often observed here that just because it's possible to do something doesn't automatically mean that it should be done. So it occurred to me as I was putting this together that a better name for this proposal might be the Security Now 4-digit Podcast Numbering Assurance Act of 2018, since this guarantees that we're going to get into four-digit Security Now podcast numbers. If we give websites the opportunity to say to their users, okay, now here's what we need you to do. Oh, Lord. So for our more technical listeners, there is a discussion of this with a lot of opinions echoing mine, like just back away from your computer, you developers. Find something else to do to add to our browsers. So I've got a link to the discussion at discourse.wicg.io, where anybody who's interested can throw their 2 or 3 cents in if you want to spend some time and just look at what's going on over there. I mean it. These show notes are produced in Google Docs. I download the PDF for them, and that's where I get the PDF that is then posted online, which Leo is looking at right now, and our listeners are looking at, those who bring it up while the podcast is underway, and I know that lots of people grab it. So, it's absolutely the case that web apps are useful, and we're seeing with, now that we've got scripting, now that we've got WebAssembly that allows native, very close to native performance of a app running on code that we got from a website. I mean, I can see, like, the next step is to allow this thing to step out of its boundary into our file system. That's the last straw. But I'm afraid it might be true. I mean, I'd be tempted just to turn that off, so that, because, well, we'll see how it develops. But the good news is they clearly recognize the danger. But the one thing we see is that the thing we have never been able to solve is social engineering attacks. Phishing attacks continue to be successful because they leverage people's inherent trust they just assume that there's authority coming from the other side. These computers they don't understand, the workings they don't understand. They want something to work, or they want to do something, and the website says, "Oh, your version of Flash is out of date. Click here to up." I mean, that's how all of these problems happen. And so you can just imagine the website that says, "Oh, in order to do this, click here and then go do the following." And in order to be useful, the app has to have access to some directories on your file system, and that's what it's going to try to get. So I don't know. I get it, but it really does sound like it's not a matter of the technology being a problem. It's the users who will unwittingly follow instructions. Historically, they've been following instructions to download updated Flash players to do what they want, or click here to get what they want. One of the core pieces of advice from the podcast that I just love this one is never download anything you are told to. Never don't download anything you didn't go looking for. Meaning, if something says you need something, just say no. Just no. It's not worth the risk. And this, to me, I think it's the social engineering abuse potential which this raises. I mean, someone could say download this and run it, and we can already do that today. Maybe this isn't any more dangerous, but bad guys keep coming up with clever ways to trick users. Last week's podcast, which was asked the question, "Are passwords immortal?" and we shared Troy Hunt's blog post. It generated a huge, really interesting set of responses from our listeners, both through Twitter and the mailbag. And I wanted to share 4 of them. Dan Stevens wrote, "Hi, Steve. I listened to Security Now episode 690, where you discussed Troy Hunt's blog post about passwords with great interest. I think good points were made on both sides, but I'm optimistic Squirrel will eventually become widely used. When credit cards came out in the 1970s," he says, "before my time, I bet everyone was saying they'll never replace cash. And they'd be right. Cash is still widely used, even in developed nations. Yet over the last few years, perhaps since contactless payments became available, I've needed cash less and less. So much so that I now leave my wallet at home and just carry my payment card. I think this shows If people are able to perceive the benefits of a new system over the status quo, a large portion will eventually switch to it. It's just a matter of time. Yes, passwords will never die, but they don't need to. If Squirrel becomes widely available enough for me to, quote, leave my password vault at home, so to speak, that's good enough for me. I'm really looking forward to the official release of Squirrel and excited to see what becomes of it. And I really thought that was a great analogy. I'm a huge, for what it's worth, credit card user, and I do remember he was right. When credit cards first happened, there was like some skepticism about it. I mean, it was like, what? And it was weird, and it was like not everyone took them, and you had to ask restaurants, do you take this or do you take that? And it was like, there was definitely, it was anything but friction free. Yet that they did happen, and they are now, I mean, that's the way we buy stuff on the web. And that's a huge, huge portion of commerce. Yet cash is still in place. And so I thought that was a great analogy for the notion of the adoption of something new over time. And on the issue of friction, one thing I forgot to mention when I was talking about this last week, but I just did want to note, is that unlike any of the other multi-factor systems, Squirrel's setup is needed once. No question about it. You got to get the app, you create an identity. It asks you to do some things to protect yourself, to write down what we call a rescue code, which is your, I forgot my password, your get out of free pass. You can back up or print out your master identity and fold it and put it away in a drawer so that you have it. Normally, you'll spread that one identity across your devices. We have a means of importing and exporting identity among computers and smartphones and things. So you sort of get an automatic backup of your identity in a multi-device mode that many of us have today. But the point is, there is some one-time stuff. But I will argue, and everyone will soon see, that is literally the only friction you ever get. And so the point I really didn't make last time is that unlike any other multi-factor system, all subsequent use is literally zero friction. I mean, even multi-factor, where you're having to snap a QR code or write down the key for your time varying multi-factor authentication. Each time you do that, every time you set that up with a new site, that's certainly not zero friction. And so much so that, I've discussed how to solve the problem of setting up a new device that now needs to know what all your codes are. And my recommendation was, while you have that device's or that site's QR code up, print it. So you end up with a sheaf of papers that you can easily allow another device you're setting up to see. But the point is, after your identity is created, the real joy of Squirrel, what it really does is, from then on, nothing can touch it. Nothing can compete with it in terms of ease. And I think that will probably be the main reason it succeeds. Is, in the example that I gave, you go to a blog site and they say, we need to know who you are. It's just like instantaneous to do that. And once people see it, it's like, okay, we need everybody to offer this. Don Williams said, does Squirrel have an option for the following scenario? He says, my employer contracts with a third party for services to be used by all employees. The third party permits access to only those users who can authenticate to the employer's security system. Therefore, the third party is depending on the employer's authentication system? And the answer is yes. The example I have given is, for example, imagine that in the future we had a U.S. identity system. That is, we wanted to try online voting, or, well, we do have things like, the IRS and Medicare. We have government provided services. The government could create a site, say identity.gov, and when you go to Medicare's site, or you go to the IRS, or you go to veterans, or whatever, those government sites could all use the squirrel domain of identity.gov. So you automatically get within your control centralized identity and authentication. So it is entirely possible for one site to use the authentication of another site. You see that in the squirrel dialog. It comes up and shows you the domain to which you are authenticating. So it's very clear what's going on. But this does allow for one site to use the identity of another. And in fact, that's sort of the example that I gave last week in answering the question about what happens if Ford purchases some other car company and wants to move its users over. We're able to use that flexibility in order to make that happen. And the user who's doing it would see that they are authenticating to the other site in order to transport their identity across. And finally, James said, "Hi, Steve. I was delighted to hear my feedback being discussed regarding delegation of access on Squirrel, and even more delighted to hear that it has been addressed already. Listening to SN 690, I was enjoying your discussion of Troy Hunt's blog post. You mentioned the importance of a frictionless process being key for the adoption of any potential successor to the current security model of username and password. In particular, you articulated the often encountered situation where people will refrain from leaving a comment on a blog post or site simply because they do not have an account, and the process of creating one falls into the too hard drawer, or I would say not worth it drawer. Consequently, people just move along and their insightful comment or reply is lost to the world, which got me thinking, parens again." He says, "The beauty of Squirrel, and as you have explained before, is that it allows a person to anonymously identify and assert said anonymous identity with a site. It allows them to do so quickly and easily. But," he says, many in all caps sites base their entire business model on knowing something tangible about their visitors, their name, their email address, a human-friendly username, etc. In the case of e-commerce, then delivery addresses, billing addresses, and credit card information would also be required in due course. In short, most sites probably will not accept the creation of an account with just one anonymous handle. They will want more. My question," he says finally, is there a provision in the Squirrel spec to allow this to be handled in a frictionless manner? And then he proposes one. He says, "I envision or propose something along the following lines. On connecting with a site for the first time, the recognition is made that the user is unknown." Okay, Squirrel has that. He says, "The site passes its challenge to you, asking you to provide and assert your identity. Could, at this moment, the protocol also allow the site, for the first time, to request other information about you that the site would want to know? Your preferred handle, your email, your real name, your billing address, and even, cringe, he says, your CC details. The Squirrel adoption the Squirrel application could then display, one time only, a list of the details that are requested by the site and which of those are considered by the site to be mandatory conditions of account creation, much the same way that Android requests app permissions at install time. The user could then choose what they wish to disclose to the site at that point and those they wish to withhold, or if they feel that the site is being too nosy, they can withdraw and the identity creation process is aborted. This would also likely assist in compliance with GDPR, as the user is being made explicitly aware of what information they are being asked to disclose and providing tacit consent in the process. And he goes on, but everyone gets the idea. So I put that in because he raises a really good point, and it has been a source of a lot of discussion over the years in our Squirrel group, and that is, what is it? The earlier specification made them what I now consider to be a mistake of doing too much. There wasn't all of that in there, but there was more. And in one of the major revamps I made, it was in pulling way back from that. We decided that what it should be is with very little exception, only authentication. That is, that's what it should only be. If we should keep it clean and simple, and it just is authentication. Many people have observed, as James has, that sites want more, and that's absolutely the case. It is also the case that if it turns out people want more, it could certainly be added, but it's not how we're going to start at the beginning. I don't think it should be more than just an pseudonymous assertion of an anonymous identity, which solves and addresses all the cryptographic aspects, because it's certainly possible then to do a form fill out thing of some sort, to add that or to have that be separate. I just didn't want to confuse the specification by bundling that in, and then it's much trickier from a privacy standpoint, from a GDPR standpoint, from a multilingual standpoint. And so the answer is no. We have decided to keep it with very little exception. There is one or two exceptions we'll eventually talk about, but I think it's better if it's just that, because then the site can say, "Oh, hi, you've established your Squirrel identity. If you would like to receive notification when someone responds to your blog posting, then we'll need an email address from you. Feel free to provide it," and so forth. And on onwards, different sites will have different requirements. I think it makes sense to let the site handle it at the site end after Squirrel is used to establish you as an identity, rather than mixing it all together. And finally, closing the loop, Joe Petrokovich said, a shout out to @SGGRC Steve Gibson, who I think gave me the idea to use Amazon S3 instead of Dropbox. He said, folder autosync job set up, monthly bill reduced from $10 to 10 cents. So that I've mentioned before that I'm using S3 to store all kinds of stuff, and I have gigabytes of stuff. But because it's just archiving, my bill is like $2.43 a month, and it's just a great repository. So I just wanted to acknowledge that, to thank Joe for the note, and to note that that's an effective solution. And Leo, we'll do our last break.
Yes,
and then look at Rowhammer attacks against ECC protected memory.
Now that's
turns out
catchy tease.
They are possible after all.
But anybody listening to this show knows that's exactly what this show is all about. Stay tuned. But first, a word from our sponsor. If you're watching Security Now, Security Now is literally brought to you by CacheFly. If you watch Security Now on our streaming site, if you're watching after the fact, if you're watching the show because you downloaded it as a podcast, that data came to you from CacheFly, our content distribution network. We've been using CacheFly for almost 10 years with nary a hiccup, no 3 a.m. calls. Just love it. Now, we don't need a web application firewall running on our CacheFly CDN, but there are plenty of people who use CacheFly for their SaaS, for their software as a service, their web apps, their websites. And for that, you might want to take a look at a web application firewall. And in particular, if you set up a web application firewall, you want to run it in blocking mode. But with your current CDN, do you have the confidence to run in blocking mode? If you're feeling boxed in by current WAF solutions, you're not alone. While others require significant changes to your environment, CacheFly makes it simple. Their WAF is designed to operate where your applications live. Over 95% of CacheFly WAF users are running in full blocking mode. That's a pretty good sign. Can your WAF say that? Shut down attacks before they happen, thanks to real-time security, visibility, and protection. Receive real-time data that pinpoints attacks or anomalies to whatever tools you already use. Whether it's Slack or Jira or Splunk or Kibana, whatever you're using, CacheFly can totally incorporate it and integrate it so you'll get data all the time or when you want it. Free up your people and systems to focus valuable time on serious threats instead of false positives, and say goodbye to headaches caused by broken internet traffic. CacheFly has been building trusted CDN relationships since 2002. They eliminate CDN outages. We haven't had one, not one, since we've been using them. And by the way, we host, besides hosting all of our podcast audio and video, all of our content's on CacheFly. Each month, you, our listeners and viewers, download petabytes of data from CacheFly, and I bet you never even thought about it. It's fast, it's flawless, it just happens, right? We wouldn't exist without CacheFly, and the costs are low. In fact, CacheFly helps you control costs because they don't bill you by the minute or by the hour. They create a payment plan that fits your spiky traffic. We have very spiky traffic. I don't have to spend a lot of time on the CacheFly site to see what my bill's going to be this month. I know ahead of time. Look, all modern infrastructures call for a modern approach to web application firewalls. CacheFly solution is designed to operate where your applications live with seamless integration. Make this the last month your WAF is not running in blocking mode. Start running in blocking mode in minutes and let CacheFly give you some sanity back. And we've got a great deal for you. This is kind of, I guess, CacheFly's Cyber Tuesday offer just for Twit listeners. Receive up to $2,000 in credits when you switch to CacheFly before the end of the year. You have till January 1st. Learn more. Get a complimentary quote. It's time to move to CacheFly. Go to securitynow.cachefly.com to get that quote and up to $2,000 in credits. Rates are based off 30% off MRC. Bill credit applied for a 12-month period. But don't wait. This exclusive offer is only available until the year ends. securitynow.cachefly.com. And boy, I mean it when I say it. We thank CacheFly for not only their support with these ads, but throughout the years for making our podcasts fly into your devices. Now back to Steve Arino and the latest from Rowhammer. It's an exploit.
So I like the name, ECCploit, exploit. Rowhammer attacks against ECC protected memory. Okay, so to sort of remind ourselves and set the context for this, as we'll recall, it was Professor Herbert Boss, B-O-S, and a team of researchers at VU Amsterdam who were the first to demonstrate how potent and potentially practical Rowhammer attacks could be. And I'll explain again what Rowhammer attacks are. But at the time, everyone took some relief from the observation that parity-protected RAM would tend to catch and thwart any single bit flips, though not dual bit flips, but that at least the presence of full ECC, error-correcting RAM, which is ECC, would provide much stronger protection. Well, now Professor Boss and a different team of researchers are back with the results of their examination of just how safe we should feel about ECC's protection from Rowhammer attacks. Their paper is titled Exploiting Correcting Codes on the Effectiveness of ECC Memory Against Rowhammer Attacks. And to give everyone a hint about what they found, the headlines in the technical press that covered this included Rowhammer data hacks are more dangerous than anyone feared. Not even ECC memory is safe from Rowhammer attacks. And potentially disastrous Rowhammer bit flips can bypass ECC. Okay, so first of all, let's remind ourselves about Rowhammer. That was 4 years ago in 2018 that this jumped onto our radar. And over the course of 4 years, there has been a bunch of research produced that demonstrated that this problem is real. As we have said, in fact, we were just talking about it last week, the difference between SSD and DRAM, whereas SSD is relatively permanent storage because electrons are stranded on a little chunk of conducting material, but on a like stranded there by insulation, so that they have nowhere to go, and their presence, their electrostatic presence, can be sensed, thus creating a permanent 1 or 0 data bit. DRAM, the reason DRAM is as dense as it is, where you can get just a phenomenal amount of data, billions of bytes of data on a strip of circuit board, is that the mechanism of storage cannot be further simplified. It is an itty bitty little tiny capacitor, which is just essentially two electrical plates separated by an insulator, technically called a dielectric. And that capacitor is charged, meaning that electrons are pulled off of one side and put on the other to create this charge, which the plates are so small and they are so close together that there is leakage. And so that this little capacitor, this imbalance in charge, tends to rebalance itself. This capacitor discharges rather quickly. Consequently, it's necessary to refresh the memory in the DRAM continuously. The idea is that in order to store at such high density, we have sacrificed the ability to store data permanently in favor of storing much greater data, and that requires the cells to be small, that they cannot retain the data for long. So what happens is, before this grid has a chance to discharge, row by row, the data is read out, and the capacitors are essentially recharged. The ones that are that have no charge in them have a 0 bit, and so they're left discharged. The ones that have a 1 bit in them are read before they have a chance to discharge so that we can't tell that they have a 1 bit stored in them, and they're essentially recharged. So that's really what refreshing is. It's recharging the capacitors by essentially dumping them all into an end of row buffer, and then reading what they had, and then recharging them all, and then going to the next row. Okay, so this is a large matrix of itty bitty tiny cells that cannot be made any smaller, or they would have been, and they need to be constantly refreshed. In the same way that hard drives are sort of on the edge of viability and rely on error correction to kind of bring them back out of the gray zone. Thus, the reason SpinRite is still useful today, because it's not physical defects on the platters that SpinRite is now compensating for. 25 years ago, it was. I was dealing with physical storage problems on the platters. That's no longer the case. Now we're dealing with the fact that densities have gone up so high and the drives have been engineered so tightly that they are counting on error correction in order to keep the data readable. So the analogy is exact here. So what's happened is that the noise margins are so tight in DRAM that what was discovered 4 years ago is if somebody hammered on a row of memory, and by that I mean continuously read from the memory, that would create enough noise, electrical noise in the neighborhood, that it could cause adjacent cells of DRAM to be misread. That's Rowhammer. Hammering on a row, and the row next to yours could be misread. And the clever, again, remember, attacks only ever get better or worse or stronger or more powerful, whatever adjective you want to use, or adverb, I guess. Wait, an attack? Yeah. So anyway, what the designers realized was you could hammer on both sides of a target victim row and make an even stronger opportunity of inducing what are known as bit flips. Actually flip the bit, cause a bit stored in memory to change. And then once they were able to do that, they figured out how to spray page tables through memory and cause the operating system to switch its page tables from the real ones to the ones they had created, and thus get write and read access to regions of memory that they weren't supposed to. So the point is, it turns out by starting at just if we arrange to read from DRAM hard enough over and over, they took that and went all the way to engineering truly effective attacks. So memory can have a parity bit added to it. You can take for example, a row of 64 bits of memory, which is generally the size that DRAM is read out in, and you can have, for example, a parity bit added to that 64 bits to make 65. And it's a very simple matter to have the hardware look at the bits that are being written, because the DRAM is also, it's read in a whole row and written in a whole row at a time. So it's easy to have hardware add a 65th bit, which will be set to 1 or 0, depending upon the number of 1 bits, the even and oddness of the number of 1 bits set in the rest. The point is that, and this is known as parity, it's a well-known process. Back in the days of paper tape, we often had 7 channels of holes punched in tape, and the 8th channel was the parity bit. And the idea being that if you punched the tape with, for example, even parity, then every row of 8 had 7 data bits to contain the ASCII characters, and the 8th bit guaranteed that the total number of punches would be an even number of holes. That way, when the paper tape was being read back, the paper tape reader would always verify even parity, and it would stop if it read something that was wrong. And in fact, when we got to optical tape readers, you would see them stutter because they were able to read and reverse the tape direction, and so they'd back up and come forward again and might stutter a little bit in order to correct the misread of a row of tape. And so you'd dramatically improved your reliability. So the idea with ECC memory, the idea with parity memory, which I want to talk about first, is that it would detect a problem. It would, if you always know that any row of memory is supposed to have even parity, that is, the number you add up, you sum the number of 1 bits and include the extra 1 you added, it should always be even. And of course, everyone should understand that you need the extra bit so that you don't, because you can't force the 64 bits to be even. You need to, if the 64 bits happen to have an odd number of 1s, then you set the parity to 1 to increase the total number of 1s by 1, thus making it even. So that's the simple logic. And the point is, it allowed the parity memory allows for the detection of a single flipped bit in the row of 64 bits. Note that it does not detect 2 bits that are flipped, because if you change 2 bits, then you have not upset the evenness and oddness of the parity of the 64. But hopefully no bits are ever being flipped in the normal case. I mean, we need our system's memory to remember what we wrote there, and for the most part it does. The idea being, though, that if a cosmic ray, which is literally one of the causes of DRAM problems, you just got a random cosmic ray come shooting through your DRAM, and it'll blast the bits. You'd like in a system which is really caring about the work it's doing, it's better to have it stop and just say, whoops, we had a parity error, than to go blithely along and do stuff wrong. So the next level up from parity is error correction. And error correction, the short version of this is it uses many more added on bits, typically 8 added to 64, so you get 72 bits in a row, and using some very complex math, which is also done in hardware and, interestingly, is proprietary, it's possible to figure out which bit flipped and fix it. So, and it's tricky again, because you've got 64 bits and you have a relatively small number of ECC bits compared to the whole, and the math that's used is able to determine which one of any of the 64 bits was wrong if one of those bits flipped. And whereas parity memory cannot detect a pair of bit flips, ECC memory will detect, but it's unable to correct a pair of bit flips. So it just sort of ups the game on the whole DRAM error issue. And so it was originally felt that parity memory would be protection, or protection from Rowhammer to the extent that it would prevent abuse of single bit flips by stopping the system, by saying, whoops, we had an error here, don't go any further. So the bad guys couldn't get anything done. Then the Rowhammer attackers figured out how to do 2-bit flips and to make it practical. There was something I was reading when I was digging through this 17-page research paper that these guys wrote, where they talked about a number of instructions which were found in the sudo command, which is used in Linuxes and Unixes to elevate the privilege of a non-privileged user. There were, I think it was 13 locations where they had identified instructions where a pair of bits flipped in the instruction would, for example, convert the instruction from a conditional jump, which was testing whether you had authenticated properly, into a move, thus neutering the jump and essentially authenticating any user who then used that instruction to elevate their privilege and thus bypass authentication. So, I mean, this stuff has been turned into practical attacks, amazing as it is. So the addition of error correction code was going to be able to, what was believed to really up the ante. It would detect single bit flips and correct them, and it would detect and not be fooled by dual bit flips. So I'll share the abstract from their research to give you the context for this. They said, given the increasing impact of Rowhammer and the dearth of other adequate hardware defenses, many in the security community have pinned their hopes on error-correcting code, ECC memory, as one of the few practical defenses against Rowhammer attacks, meaning we haven't come up with a solution for this. Specifically, the expectation is that the ECC algorithm will correct or detect any bits they manage to flip, meaning attackers manage to flip in memory in real-world settings. However, the extent to which ECC really protects against Rowhammer is an open research question due to two key challenges. First, the details of the ECC implementations in commodity systems are not known, which came as a surprise to me. I just assumed we all knew about that. Turns out it's proprietary. Second, existing Rowhammer exploitation techniques cannot yield reliable attacks in the presence of ECC memory. In this paper, we address both challenges and provide concrete evidence of the susceptibility of ECC memory to Rowhammer attacks. To address the first challenge, we describe a novel approach that combines a custom-made hardware probe, Rowhammer bit flips, and a cold boot attack to reverse engineer ECC functions on commodity AMD and Intel processors. To address the second challenge, we present ECCploit, exploit, a new Rowhammer attack based on composable, data-controlled bit flips and a novel side channel in the ECC memory controller. We show that while ECC memory does reduce the attack surface for Rowhammer, ECCploit still allows an attacker to mount reliable Rowhammer attacks against vulnerable ECC memory on a variety of systems and configurations. In addition, we show that despite the non-trivial constraints imposed by ECC, ECCploit can still be powerful in practice and mimic the behavior of prior Rowhammer exploits. I won't go digging deeper into this, except to note that these guys pulled this off. It turns out that the ECC details are contained on chip and are undocumented by Intel or AMD. So it was first necessary for them, in order to figure out how to bypass error correction, to determine, to reverse engineer the error correction algorithms. That is, to figure out exactly what math was used on the 64 data bits to create the ECC tag, as it's called, to compute ECC, in order to know how to flip bits deliberately that would bypass error correction. They did that through a brutal process of reverse engineering. They reverse engineered 1 AMD and 3 Intel chipsets to figure out what was going on. They recognized that normally the chipset that software is running on is made aware, or it is not obscured from software that is running on the hardware platform. So the point being, it's possible for software to know what hardware architecture it's on. That would then tell it what the respective ECC algorithm is, which would then allow it to choose the proper Rowhammer attack in order to flip bits on that particular platform. So while it is definitely the case that error correction code does make Rowhammer attacks more difficult, it does not solve the problem of Rowhammer. And one thing I learned from reading this paper, which just made me sort of close my eyes and shake my head, was it turns out that the refresh rate of DRAM, we have always known that it decreases, that it has a performance impact. That is, since refreshing is taking some of the RAM system's bandwidth for no good purpose, rather than just running through row by row by row, reading and rewriting that memory, that's going to consume some of the bandwidth. Thus, we have known that whereas one of the mitigations for Rowhammer is increasing the refresh rate in order to have the cell's data be stored further from the noise margin, that is, more firmly, having the 1 bits more firmly won, thus making it more difficult to have noise induce a flip. We've known that. It turns out that there are instances where systems are very power critical. They absolutely have to run at low power. So it turns out that refresh is deliberately reduced, because not only does it reduce performance to refresh at a high rate, it increases power consumption. So there are places where refresh rate has been deliberately compromised, and ECC is used as a prophylactic to and I was, of course, again, reminded of hard drives that have done the same thing. Hard drives are now relying on error correction to make up for the fact that they're no longer able to guarantee that they're able to read back the data without correction. Similarly, it turns out error correcting DRAM is now being used as a performance prophylactic to solve the fact that in where power has been reduced, DRAM refresh rate has been reduced to compromise on power, and error correction is then assumed to be part of the system to bring back the reliability that was lost from having DRAM refresh rates reduced, which, again, as an engineer, I just shake my head and I go, well, okay, good luck to you. So anyway, that's the news. The headlines were correct, although we're really out in the academic weeds at this point. Again, we're sort of where we were with Spectre and Meltdown, in that the real danger is in shared hosting environments where bad software has an opportunity to run alongside good software and is able to, by being mischievous, get access that it shouldn't have across protection boundaries. It's true that we don't want bad software which we inadvertently run in our own workstations to have greater reign in our system than the OS wants to give it, and Rowhammer attacks allow that. That's why our browsers were immediately hardened against Rowhammer attacks, because the browser is the way that you have untrusted stuff running in your system, which again is why I'm not so sure I'm bullish on the idea of giving our browsers, like releasing our browsers from their sandbox and allowing them to have access to the native file system that they're running on, but we'll see how that goes. Similarly, if you've got something that is already hammering away at your system's RAM, you've already got malware running in your system, and that's not a place you want to be. So anyway, I think I wanted to address this because the popular press, the technical press, has talked about how Rowhammer is now functional in ECC memory. And it's like, yes, if the chip is one whose ECC has been reverse engineered, if it knows where it's running, I would argue anyone who, like state level actors, where a huge amount of resources could be mounted to attack a specific system, a specific thing where it could be known what the hardware platform is. People could be put on the task of reverse engineering the ECC algorithms for that particular hardware platform. Then the Rowhammer attack could be designed to flip the bits specifically necessary to achieve a specific goal on that specific platform. Look at all the times I had to use the word specific. I mean, it's like really specific, really focused attack. Then we have a problem. But for us, most of us, it's of academic interest to see how something from 4 years ago keeps coming back. Attacks keep getting stronger against all the mitigation that is brought to bear. from a theoretical security standpoint, really interesting, but I don't think it really affects us directly very much.
Well, I hope those guys got their PhD. Interesting. That's all I can say.
Well, 4 years ago, I think that whole team probably graduated. They've got their doctorates and they're gone. And so Herb has a new team of PhD students who says, okay, you want to be doctors? Let's do it again.
No Nobel Prize for that, but a PhD is a good start.
That's right.
Yeah. Steve, we've done it again. We've completely dissected and hammered upon the rows of information, of security information from this week, and there's nothing left but pulp.
Among us and our listeners.
Yeah. Well done. Bravo. I hope you enjoyed watching the show. Now, some of you watch live, and if you'd like to do that, you're more than welcome. That's the best way if you want to interact with the show to get in the chat room at irc.twit.tv. Is do it while the show's live. That's Tuesday afternoons, 1:30 Pacific, 4:30 Eastern, 21:30 UTC. You can watch it twit.tv/live. You can also get the downloads. We offer a variety of ways to download it. Steve's got the 64 kilobit audio at his website, grc.com, along with transcripts, which are handy if you like to read along as you listen. I know a lot of people do. And, I bet you there are not a few people who have a complete collection of all the audio and a complete collection of all the transcripts so that they can search it, refer back, and so forth. That's a very good idea. Put it in binders. Put it on your shelf. You'll impress your friends. grc.com. While you're there, pick up a copy of SpinRite, world's best hard drive recovery and maintenance utility. Find out more about Squirrel. Everything else is free. Lots of freebies on there, including Shields Up to test your router, perfect paper passwords, perfect password haystacks, everything. It's fun, and even health advice and vitamin D information, and it goes on and on. It's a treasure trove. grc.com. If you want to get a hold of Steve, you can leave a feedback message there at grc.com/feedback, but you also can DM him at Twitter. He's at SGGRC on the Twitter. We have audio and video at our website, twit.tv/SN. You can download whatever you like there. For most people, the most convenient thing to do is get a podcast app on your phone or your tablet and subscribe. That way you'll get every episode automatically the minute it's available. It's the fastest way to get the downloads without having to think about it. We should actually make a feed of the show notes, too. I bet you people would appreciate that at some point. But for now, the show notes are at grc.com. I think that's everything. Thank you, Steve. Have a great weekend.
And we'll be back in December.
Holy cow, how did that happen? I will not, actually. I'm going to be in New York City next week for our annual trip to see shows on Broadway.
Must be Jason time. I do remember that you
will be Jason time. It'll be Jason time. And then I'll be back the week after that. And we have planned a great best of. I don't think we've ever done a best of with Security Now.
We haven't, but we're going to this year.
We're going to let you take a couple of weeks off because Security Now falls on Tuesday, which is Christmas and New Year's.
Yep.
So we're just going to play that best of twice, and we'll be back doing live shows on the second Tuesday of 2019. That's Tuesday, December 8th. January 8th. Thank you, Steve.
Thank you, my friend.
Have a
See
great
you next
night.
week.
See you next time. Bye.
Security Now.